Welcome, cosmic explorers, to an incredible journey beyond our solar system. Today, we're diving deep into the thrilling search for exoplanets, the quest to discover new worlds orbiting distant stars. Imagine planets unlike anything we've seen, gas giants hotter than stars, rocky worlds with alien skies, and maybe, just maybe, a twin to Earth where life might thrive. How do we find these hidden gems? What do they tell us about the universe? And could one hold the key to finding life beyond our planet? Buckle up, because we're about to embark on an epic adventure that will stretch your imagination and leave you burning with curiosity. Let's explore the search for exoplanets together. Picture the night sky, a vast canvas of twinkling stars. For centuries, humans gazed upward, wondering if other worlds circled those distant lights. Our solar system, with its 8 planets, was all we knew: Jupiter's stormy gas clouds, Mars' red deserts, Venus' scorching surface. But in the 1990s, a revolution began. Astronomers discovered the first planets orbiting other stars, opening a new chapter in our cosmic story. These exoplanets, short for extrasolar planets, are worlds beyond our solar system, and today, we've confirmed thousands, with countless more waiting to be found. The search for exoplanets isn't just about mapping the cosmos, it's about understanding our place in it. Doesn't that make you wonder what strange and wondrous worlds are out there? Let's start with the dawn of this quest. For a long time, finding exoplanets was a dream, not because we doubted they existed, but because the challenge was enormous. Stars are billions of times brighter than planets, drowning out their faint light like a spotlight hides a firefly. Early astronomers speculated about other worlds, but tools were too crude to detect them. The breakthrough came in 1992, when Alexander Wolszczan and Dale Frail found 2 planets orbiting a pulsar, a rapidly spinning, dead star blasting radiation. These weren't cozy worlds, but harsh, rocky ones baked by their host. Then, in 1995, Michel Mayor and Didier Queloz, Swiss astronomers, discovered 51 Pegasi b, the first exoplanet around a sun-like star. This, hot Jupiter, a gas giant orbiting insanely close to its star, stunned scientists and earned a Nobel Prize in 2019. The floodgates opened, and the hunt was on. How do we find these elusive worlds? Astronomers have developed clever methods, each revealing different clues. The first big technique is the radial velocity method, or the wobble trick. Stars and planets orbit a shared center of gravity, so a planet's tug makes the star wobble slightly. This shifts the star's light, stretching it redder or bluer in a pattern we can measure with spectrographs. The bigger the planet and the closer it orbits, the stronger the wobble. 51 Pegasi b was found this way, orbiting its star in just 4 days. This method excels at finding massive, close-in planets, but it's tricky for small, distant ones. Still, it's given us hundreds of exoplanets, painting a picture of alien systems. Isn't it amazing how a star's tiny dance betrays a hidden world? The real game changer, though, is the transit method. Imagine a planet crossing in front of its star, like a fly buzzing past a light bulb. This dims the star's light slightly, a dip we can measure with telescopes. The size of the dip tells us the planet's size, and the timing, say, every 10 days, reveals its orbit. NASA's Kepler Space Telescope, launched in 2009, mastered this, staring at 150,000 stars for years, catching thousands of dips. It found planets from Earth-size to giants, some in tight orbits, others far out. The catch? We need the planet's orbit to line up just right, edge on from our view. Even so, Kepler confirmed over 2,600 exoplanets, showing us the galaxy is teeming with worlds. Doesn't that make you eager to know what's out there? Other methods add to the toolbox. Gravitational microlensing uses Einstein's general relativity. A star's gravity bends light from a distant star behind it, acting like a lens. If a planet orbits the foreground star, it tweaks the lensing, briefly brightening the background star in a unique way. This can spot far-out planets, even small ones, but it's a one-time event, hard to repeat. Direct imaging is tougher, capturing a planet's faint light by blocking the star's glare with coronagraphs or star shades. Telescopes like the Very Large Telescope and the James Webb Space Telescope have snapped a few, like the giant HR 8799 system, with 4 planets glowing in infrared. Each method unveils new worlds, building a cosmic catalog. What strange planets might we catch next? Let's meet some of these alien worlds, because the variety is jaw-dropping. We've found hot Jupiters like 51 Pegasi b, gas giants roasting at thousands of degrees, orbiting stars in days or hours. Their intense heat puffs them up, defying our solar system's norms. Then there are super-Earths, rocky planets bigger than Earth but smaller than Neptune, like Gliese 581g, once a contender for habitability. Mini-Neptunes, with thick gas layers, blur the line between rocky and gassy. Some exoplanets defy imagination, lava worlds like 55 Cancri e, super-Earth, so hot its surface may be molten rock, or rogue planets, drifting free without a star, possibly ejected from their systems. The diversity stuns us, hinting at countless possibilities. Can you picture a planet with oceans of lava or no sun at all? One big question drives this search: could exoplanets host life? We focus on the habitable zone, the Goldilocks region around a star where liquid water might exist. Not too hot, not too cold, just right. Earth sits in our sun's habitable zone, so we hunt for similar worlds. Proxima Centauri b, orbiting the closest star to us, just 4.2 light-years away, is a rocky planet in this zone. Its red dwarf star is dimmer than the Sun, so the zone is closer in, but flares might blast it. The TRAPPIST-1 system, a cool red dwarf 40 light-years away, dazzles with 7 Earth-sized planets, 3 in the habitable zone. Water, a key for life as we know it, might pool there. We dream of biosignatures, gases like oxygen or methane, hinting at alien life. Doesn't that spark your imagination? Let's dive into the tools of the trade. Early discoveries relied on ground-based telescopes, like the ones Mayer and Cuello used for 51 Pegasi b. But space telescopes took us further. Kepler, from 2009 to 2018, revolutionized the field, finding thousands of candidates. Its successor, TESS, the Transiting Exoplanet Survey satellite, launched in 2018, scans nearby stars, spotting planets from Earth-size to giants. The James Webb Space Telescope, launched in 2021, peers in infrared, studying exoplanet atmospheres by catching starlight filtered through them. Spectral lines reveal water vapor, carbon dioxide, or methane, clues to composition and maybe life. Ground observatories, like the European Southern Observatory's Very Large Telescope, refine measurements. Each leap in tech brings new worlds into focus. What will we see next? Now, let's explore exoplanet atmospheres, because they're a window to habitability. When a planet transits, some starlight passes through its atmosphere, if it has one. Telescopes like Hubble and James Webb analyze this, spotting chemical fingerprints. For example, HD 189733b, a hot Jupiter, shows signs of water vapor and methane, though its scorching 1000-degree heat rules out life. Smaller, rocky worlds are trickier, but Webb's power lets us probe super-Earths and mini-Neptunes. We look for water, oxygen, or odd mixes hinting at biology. Some planets might have thick clouds or hazes, hiding secrets, but each spectrum teaches us. Imagine finding a whiff of life. How would that change everything? What do exoplanets tell us about planet formation? In our solar system, rocky planets like Earth form close to the Sun, while gas giants like Jupiter sit farther out. But exoplanets break the rules. Hot Jupiters orbit so close they'd roast, suggesting they formed farther out and migrated in, pulled by gas disks or gravitational tugs. Super-Earths and mini-Neptunes, common in the galaxy, hint at diverse processes, maybe from dusty disks or chaotic collisions. Computer models simulate these, showing how dust clumps into rocks, then planets, shaped by gravity and radiation. Our solar system seems special, not the norm. The variety challenges theories, pushing us to rethink how worlds are born. Isn't it wild how alien systems rewrite the rules? Let's zoom out to the big picture. The search for exoplanets ties to the universe's story. After the Big Bang, stars formed, forging elements like carbon and oxygen in their cores. Dying stars exploded, seeding gas and dust for new stars and planets. Exoplanets show this cycle varies wildly. Some systems have one planet, others dozens. The Kepler mission suggests there are billions of exoplanets in the Milky Way alone, maybe more planets than stars. Statistically, rocky worlds and habitable zones are common, raising hopes for life. This quest connects the cosmos past, star birth, element forging, to its present, a galaxy teeming with worlds. How does that shift your view of our place? The hunt for life is the holy grail. We seek Earth-like planets, rocky, temperate, with water. Proxima Centauri b and TRAPPIST-1's worlds excite us, but red dwarfs, common in the galaxy, flare violently, maybe stripping atmospheres. Larger stars, like our Sun, offer wider habitable zones, but planets there are harder to spot. Biosignatures, like oxygen paired with methane, could signal life, though geology mimics some signs. Future telescopes might catch these, but false positives worry us. The Drake equation guesses at alien civilizations, factoring planets, habitability, and life's odds. We don't know the answers, but each exoplanet brings us closer. Could we be alone, or is the galaxy buzzing with life? Let's tackle challenges. Stars outshine planets, so direct imaging is tough, needing tricks to block glare. Transits need perfect alignment, missing many worlds. Radial velocity favors big, close-in planets, not Earth twins. Distance muddies things. Light from far-off stars takes years, even millennia, to reach us, showing past states. Atmospheres are faint, needing sensitive tools. Yet, scientists push forward, combining methods, refining data. Each hurdle sparks innovation, like star shades or AI to sift signals. The quest is hard, but that's what makes it thrilling. What breakthroughs will crack these puzzles? Now, let's meet some star players. Kepler 452b, 1,400 light-years away, is a super-Earth in the habitable zone of a Sun-like star, a cousin to Earth, though hotter or gassy, we're not sure. LHS 1140b, 49 light-years away, is rocky, in a red dwarf's Goldilocks zone, a prime target for habitability. WASP 12b, a hot Jupiter, orbits so close its star distorts it into an egg shape, a bizarre world. Rogue planets, like PSO J318.5-22, drift starless, glowing from leftover heat. Each discovery paints a wilder picture, from icy giants to molten rocks. Which world captures your imagination? Future missions fuel excitement. The James Webb Space Telescope already probes atmospheres, hinting at habitability. The Nancy Grace Roman Space Telescope, set for the 2020s, will use microlensing to find distant worlds. The European Space Agency's aerial mission, launching late this decade, will study hundreds of exoplanet atmospheres, seeking patterns. Ground-based giants, like the extremely large telescope, will image planets directly, pushing limits. These tools could spot Earth twins or biosignatures, edging us toward alien life. The pace quickens, and the cosmos beckons. What will we discover in the next decade? Let's bust some myths. Exoplanets aren't all alien Earths, many are hostile, scorching, frozen, or gassy. Finding life isn't guaranteed, habitability needs water, stability, and luck. They're not close, most are light years away, beyond reach for now. And no, UFOs aren't proof of exoplanet aliens, science seeks data, not stories. The real tale is epic, thousands of worlds, each unique, reshaping our view. The search blends astronomy, physics, and dreams, driving us to explore. Doesn't the reality outshine the fiction? What does this mean for us? Exoplanets tie us to the cosmos. Stars forged our atoms, planets cradle life, and the galaxy might host others. The search challenges our tools, theories, and imagination, asking, are we alone? Earth, a pale blue dot, seems rare, yet billions of worlds hint otherwise. This quest, born of curiosity, unites us, from ancient stargazers to modern scientists. Each new planet fuels wonder, pushing us to dream bigger. You're part of this cosmic story, connected to distant worlds. As we near the end, let's gaze ahead. The search for exoplanets grows, with thousands confirmed and more to come. New telescopes, AI, and missions will map atmospheres, hunt life, and unravel formation. Could we find an Earth 2.0? Might we detect alien signals? The universe is vast, and we're just starting. What questions stir your mind? How will new worlds change our view? Thank you for joining me on this epic dive into the search for exoplanets, discovering new worlds. I hope your curiosity is blazing. If you love this cosmic adventure, hit that like button, subscribe, and ring the bell for more journeys into the unknown. Drop your thoughts in the comments. What blows your mind about exoplanets? What mysteries should we explore next? Until then, keep looking up, keep wondering, and let's unravel the universe together. See you in the next video, Cosmic Explorers.